Hello, welcome to the instructional video for fitting the 113 Racing camber adjustment kit to the Peugeot 206 subframe. If you're here looking for entertainment, this is absolutely not the video for you, but stick around if you like. Laid out here is pretty much everything that you will need and what comes in the kit. You can get by with less. The more you have, the easier it is. So I'll bring you in and we'll have a look at what we've got here and we'll get started. All right, first thing you're going to need is a drill and a range of drill bits. Secondary to that is a die grinder and a couple of different bits for your die grinder. You don't need a die grinder. You can just grab a set of bits. Now, I got these from AliExpress for like 20 bucks for a full set. You can buy just one for a few dollars. They're really handy and you can run them in a drill, but a drill runs at 3,000 RPM. These run at about 20,000 RPM. So it'll take you like 10 times as long with one of these as with one of these, but it does do the trick. If you've got an air compressor, air tools are becoming obsolete now. They're being replaced by cordless. So you can buy bulk lots of really high quality air tools on Marketplace for next to nothing. So quick tip. You'll need an angle grinder, obviously, and a welder. Now, a finger sander, belt file, power file, mini belt sander, whatever you want to call these things. I've got a million different names. Super handy. This is a really cheap one that I even got as a second-hand lot, so it was even cheaper again. Really handy for getting into really weird places and getting the paint off. However, you don't need it. You get away with an angle grinder. Some marking materials and measuring materials. I would recommend a scribe as opposed to pens. They're way more accurate. Clamps are optional. Really handy for holding things down, but it's going to cover your alignment holes, so up to you. You will need a couple of M14 camber bolts. Now, these are from a D40 Nissan Navara. They've got different names around the world, but D40, D22, and D23 or NP300 Navara. I'm pretty sure all use the same bolt. It is a M14 thread, doesn't matter. It has a 40mm concentric head and a 40mm concentric washer. You will need at least 50mm of smooth shank, and it needs to be at least 90mm long. These bolts are way too long and the groove in them doesn't come up far enough, so you actually need to modify them a little bit, grind the groove in a little bit further and grind the flat in a little bit further so that they actually cinch up properly. There are other bolts out there, but I can't find dimensions for them that might work. I know Toyota uses a similar bolt. It's in like the Avensis van thing. I think Hilux have the same bolt. Volkswagen, I believe, also the Transporter uses a similar bolt, but I don't know what the length is and what the size of the washer is, but there's other bolts out there that will work. I just know that these ones work, so that's what I've got. And then the kit itself. So I've changed the kit from the prototype to the final a little bit. I've cut this whole end off. You don't really need it. It's just extra material. This was a bit crooked. This was a bit crooked. This was a bit crooked. But I've fixed that. So you get a top template and a bottom template. You'll get two of these little parity guys. We actually need to fold these, and I've made the fold lines a little bit more obvious than this little tiny dent here and this little tiny dent here and this little tiny dent here and this little tiny dent. So I'll fix this. The flange that we're about to bend is also way too large and gets in the way, but if I make it any smaller, you can't grab it to bend it. So I've left it big and then you can cut it down later, or you can just leave it not necessary. Two of these guys, four of these fellas, and a few other parts that I didn't have in the prototype that I've included in this kit. Just little tiny bits and pieces like this. And then there'll also be a bunch of the stoppers that we're going to weld on last thing. I've included them just in a tear off thing. It's way easier than trying to source like this much 5mm material. So that's what we need. Let's get started. So first things first, we'll fit these little parrot guys. Now these actually fold up. Now the flange that we're going to fold is from that point to that point. Again, they're easier to see on the new design, and they're way too long, but I've left a lot of material here so that you can actually fold it properly. If you've got a bender, line the bender perfectly up with the dots. If you don't, if you're bending them in a vise, which I'll show you how to do, you need to give yourself half the thickness of the material, so come down about 2mm down if you're grabbing this flange, or 2 millimeters this way if you're grabbing this flange, just so that you get your bend in the right spot. But if you're using a bender, it's right on the mark. Now, this mark here varies because all these subframes are different. They're not exactly the same. So it's a matter of, we need to cut this piece off so we can get it to fit. Once we get that cut off, then we can work out where we need to bend and how much we need to bend. And that's the reason these don't come pre-bent, because they're all different. So we grab our top flange and familiarize yourself with how this fits, because again, these are all different. You can see on this one here, it doesn't want to sit down properly because it's got a weird lump thing here. But on this side over here, it sits down perfect. So they're all different. They're all weird. So we drop the template on top, and then the top of this hole and the top of this hole will line up with the factory holes, and we don't ever change the factory holes. If you're in there drilling, grinding, whatever, make sure you don't do any damage or make any movements to the top of those holes, because that's where you need to line your template up with each time. So we line the template up, and this line here lines up with the edge of the steel, and then this line here should also line up perfectly. And then I've got a hole for reference, so you can put a M10 bolt in there to line it all up. So you can see, basically we need to cut this flange off here. So we cut down there and along there, and then we replace that flange with this flange and this flange. So let's get that cut first of all. So you can see here, I'm just checking it with the template over and over again. I don't know how well you can see that, but it's not actually lining up. So the template's on where it needs to be, and I can't get it to line up with the hole, so I need to keep taking more material out until it does. And now I've got that lining up perfectly. So that's where that needs to be. All right, now that we've fitted the little toucan dude, just do a quick draw around everything that we need. And remember, this is going to fold up on the inside here, up like that somewhere. And then this little guy here. Because we're going to be welding that, we're going to want to grind all that paint off. So I will just use my little finger sander. Again, you can use a grinder if you can get in there, sandpaper, whatever, to get that paint off. I'll do it with this right quick. All right, now that that's done, first thing I will do is get the back one ready. So drop it in, drop the template on, get it all nicely lined up. And then we just sort of bump the little reinforcing plate around until it's lined up perfectly with the original hole at the back and the template at the front. So when you're looking down through it, it lines up perfectly. That one's just got to go back just a tiny little bit. Once I've got that all lined up, I will take the template off. Actually, no, I can probably leave the template on, but I will scribe that line. The reason I put the little packer in first is because when we're scribing through the template, there's like a 2 mil gap, which is what the packer is there for, to build it up so that we're level, so that our washer and our bolt can skim across the top of the subframe and not get locked down in the little hollow. So the reason I put that in first is because if we're trying to mark down a little gap, if we're on a bit of an angle or whatever, we'll be out. So by putting that in, holding a lot of pressure on it, we can get a nice tight scribe line and everything's in the right spot. Don't take this whole getting it lined up thing too ultra serious, because everything can be adjusted later on with the die grinder. So in the spirit of progress, we can now see that is where that one sits. So I can place it back on there at any time, exactly where it needs to go, by lining the back of it up and then just getting the alignment with the scribe marks. And we'll get back to welding that on later. First things first, we need to bend this fella up. So again, once we've got it set up in there, we can see that that bend line there is the start of our bend, but it's gonna come up a little bit and then need to bend some more. So I'll put an initial bend in it right on that mark. And then for the front, I'll bend it on these marks here. What we actually are looking for here is when the bolt is in here all the way to the front, like so, this is going to be the stopper for it. It's also a flange to reinforce all of this. So this is where we want the inside of our fold to be, is there. So when we bend it, if we bend too far up and we can't get the bolt all the way to the front of the hole, we'll need to grind a little bit out. If you bend too far away and there's a gap here, you won't get all your adjustment this way when it's back this way. If there's a gap there, it'll sit here and not here. All we need to do is just weld a little bit of a packer on there, or put a shim in, or just not adjust all the way back. I'm looking for maximum camber adjustment, so I want it to go all this way. So if I'm a little bit out, I want it to be on the long side. So you can use a pan brake or a press brake, whatever you've got. I'm just going to use a vise to show you that it is possible. You can also just use a couple of shifters if you're really, really good with shifters. So again, because I'm using a vise, I want it just off that mark by about half the width of the material. So if I go about there, actually, that's about probably a mil off. It's about right. Doesn't matter which way you bend this, you just have to make sure that you bend one each way. Is that right? Yeah, one each way. Like so. And then if we test it with our bolt, the bolt's just, yep, it's all the way and it's just touching, so that's about perfect. So then when I spin this around, it goes to there, we are just not quite all the way back. So probably needs to be maybe a half a mil closer, but it's good enough for the girls I go out with. And now this little tab on the end, now because I've bent this, I'm going to have to grab it outside here. I'll get it right on that mark and I'll put my initial bend in. So that's a mil off that mark. I'll just move up on this really slowly because it's a bit of a complicated little guy. So he sits in there. It can come up probably 45 degrees. Something like that. Yep. And now, I don't know how well you can see. If I keep bending there, I'm going to foul on the inside here. So I probably want to move up to about where those scratches are, about there, and bend again. So if I move that out to something like that, we'll bend it up a bit higher. So this is the reason we sneak up on it, because you need to put that radius in it before you bend it all the way, because if you start bending all the way to here, now you want to put a radius in here, it's really, really difficult without a press. So you sort of want to put a few bends along it and then get it up to where it needs to go. So I need to go a little bit less here and a little bit more there. So that's exactly where I want it. So same thing, I will scribe that line now. And that's exactly where that fella sits. So now we can weld these two guys in. There and there. Now again, this is where clamping comes into it. You can obviously clamp that in there, but when you're putting the clamp on, you need to be very careful not to move anything, because your lines, obviously your scribe lines and your visual cues and everything are from the top. So putting the clamp on the top, you kind of lose those visual cues, but this little tiny guy, I can sort of see around it. So get them welded on, I'll get back to you. All right, and that is the welding done for, well, a quarter of it. So tolerances are really tight around here. So most of your weld you're going to have to grind off. You obviously need to make this nice and flat. You could TIG weld it if you wanted to, or MIG it. I try not to build up too much product because I need it flat. If you want it to be perfectly smooth, you could do that. In here, you need the washer of the bolt to get hard up against that, so you have to grind a lot of that out, which is where the die grinder comes into it. And I don't know if you saw, but up in the back here, without playing around with this flange for ages, I had a bit of a gap there, so welded a bit of a gap up. This one over here, we just need to make this nice and flat. It would be nice to actually bridge this gap on the end here. I suppose you could probably do it with weld from there to there, and then grind it back in again, which I probably will do. Because I just don't want this to tear out of the end here, although we are going to put a stopper across the front here, so it's probably not 100% necessary, but I'll probably just buzz that in anyway. And then we need to grind this weld off nice and flat so that it's good for the washer to go all the way across without doing weird things. So I'll do that off camera. I'll come back. All right, so now I've got these smoothed off. It's a matter of getting these guys to go in. So as you can see, I'm a little bit off angle here, so it drops in, but when it tries to line up at the bottom, it gets really tight really fast. So I just need to take a little bit out of the back of that one. Same thing with this one here. It crept forward on me when I welded. So we can get these guys in, and then we also need to drill out the front of them. So I found the easiest ways to come through with some sort of a pilot, so like a 4mm, kind of eyeball the middle of it, run through like that, then run through with a 10, and then if you've got a 13, hit it with a 13, or ideally if you've got a 15, hit it with a 15. But once you get into here, it's going to bite these corners, and it's going to make it very difficult, and that's where your die grinder comes in, just to finish opening those holes out. So fuck me. All right, so I just realized that you guys were zoomed in for that entire thing and you probably missed it. So I've drilled those out and jump onto a die grinder now with probably a Christmas tree bit, and I'll finish rounding those holes out. Now, always double checking with my template because what I want my final holes to look like. So I'll put that on. So I need to take out where I welded on here. I need to take a little bit out. I'll draw that on, and where this is sitting forward, where it moved when I welded it, I'll also draw that on. So I know I need to take a bit out of my packer. This front one is what it is. It's sitting up on. I need to take a bit out of my template here, so I might do that. Take a bit out of there so I can get this to sit in here properly. So it looks like hell. So change the burr on my die grinder. I'll get onto that. That is all done. So we chuck the template on. You see I had to modify the template a little bit to clear here and here. But we get it lined up with that hole, lined up with this hole, and lined up with that hole from your angle. You're probably seeing a little bit of, but whatever. So again, if you mess up on this step, not a huge deal. It just means that when the bolt is in, it's going to be a little bit loose, and I've left the ends a little bit loose so that you can, because as you're twisting like this, the bolts want to move through an arc. So I've left the top factory positions tight, so it won't move in a factory position. But when you're down here on both of them, it will be a little bit loose forwards and backwards. And if you find that if you're hitting ripple strips or whatever, and the bolts are slipping because they're only a friction fit at that point, what I would suggest would be to work out where the bolt wants to sit in the hole, pack the inside of it up with weld, and re-drill it so that it's tight in the position where you want it locked in and set. I've made it deliberately loose so that you can grab all different points of camber and caster. So if you're finding you're having issues, just build these up and then re-drill them exactly where you want, tighten the bolts up, and you should be good. So that's pretty much the top done. It's very, very simple. The only other thing we need to do is put the stoppers in. All right, now that we've got it flipped upside down, we drop our template on. Because of the deepness of these, I guess it's quite hard to line this up. So this sits hard up against the ARB mount, and then you might need to actually drop the bolts down through it to get it perfectly in alignment. Make sure that it fits. You might need to do a little bit of grinding on it, but it fits pretty much all the subframes that I've worked on. And then we put these guys here in. So this fella here goes on the front, and he pretty much sits exactly where he needs to be. And then the bottom one, you've got to, again, twist to line up. We drop this on, and easiest thing I've found to do is put a bolt down through the factory hole to get everything perfectly lined up. And then just using something pointy to line the bottom of it up, and then very, very carefully take the bolt back out without bumping anything. And that's exactly where that guy needs to go. hold him down and scribe it. And I'll just also scribe around the outside so I know where to clean up. And then the back one, it's kind of an eyeball job. So actually that's pretty good right where it is. Now, this is a little bit big for this one. I did have a smaller one in the kit, but it was kind of a bit confusing. If you drop it on there and you sort of look in here and you can notice a gap, you might just need to grind just a little bit off of here, or take a little bit more out of the corner here just to get it to sit down flush. Otherwise, it doesn't really matter. It'll compress when you do the bolt up, but if you're concerned about it, whatever. And then this one obviously has these flanges on it, which is different to the top, and the flange gets in the way of the washers. So we need to grind down the flange so that the washer can drop in. And we also then will have a hole in here, which is what these little fellas here are for. So I will include these in the kit. I was going to get used to make them yourselves, but it's a bit difficult. So this one sits in here. The one in the kit's better, and it needs to profile a little bit. So get it lined up approximately where it needs to be. And I would suggest just start welding it. And then as it gets hotter, you'll be able to bend it around, making sure that this plane here is 100% clear of weld and everything, because the control arm needs to fit in here like that onto that flange. So nothing can protrude below the line of that level. So you see there's a few mil gap there. If you're going to weld along the top there, just make sure you don't add too much weld. Otherwise, you'll have to grind it off to get your control arm in and out. And then I've included 4 of these little fellas. What we will do is these actually sit out here a little bit further to where that lines up. So it's, you notice it sits above that. So we need to cut from here down to here, cut all that out. And then this fella goes in the back side there. And then I've included 4 of them so you can double it up and make them the same width as the original flange, just to put basically all this back in here, what we're cutting out. So I'll get this tidied up and we'll do it, and it'll make more sense then. All right, fast forwarding a second, we've got that tidied up. I needed to take just a tiny little bit off of this corner here because it was hitting. So I did that to make it sit nice and flush, lined up with my scribe lines, so we can weld these in fully now. Again, I'm going to weld across the front of this and all the way along here. I'm going to have to grind most of that back off again, so it'll be fine. And then we can get on to cutting flanges. All right, now the smoke is cleared. I've done the same thing on here, so I've just smoothed this one out, thrown the template on, and elongated my holes. Obviously this one here, we're probably going to have to do something about those welds just to try and make sure this bolt sits nice and flush. So no, it looks like it's going to clear. So now we need to work out how much we need to take out for these. So as I mentioned earlier, it's a matter of putting the bolt in here, pushing it all the way to the back, and then sort of draw around the washer. That's what we need to take out. But this one here, we're going to cut it all the way from this ridge here, all the way from there, all the way to wherever it's flat. So down there like that. We're going to take all this out, all the way along. So chop that out. This one down here, we don't. Put that on. We're just going to grind that little bit there out. So I'll probably do that with the die grinder. And we'll get these bolts in. You can see here we've taken off this entire corner, and that's where these little pieces here come in. So they now sit in there like that, and we'll weld them all in, and then we'll grind our profile back out for the washer. So we just extend this over here a little bit more so we can get a weld on here, a weld on the back side, a weld on here, and we can get a weld on the inside and then grind most of it back out. So it's probably not going to do much, but whatever. And then, I don't know how well you can see it, but there's a hole in this end here now that we need to cover up. So it just protrudes through the backside, the washer. So once we weld this on, again, we'll need to grind a little bit out of it. But I'll start by welding this end and along the top here, and then I'll bend this end around. And then we can get a weld on the bottom side here, making sure we don't be lower than the mounting surface for the control arm. Otherwise it'll fail and we'll have to grind that off. I've also done a bit of tidying up in here too, because I'll need to obviously paint that. And these subframes are completely hollow inside, so you want to make sure that you fully blow all the swarf and stuff out of it. Otherwise it'll sit in here and rust and cause you issues. So let's weld these on. All right, I have to be careful putting that much heat into that thin of material at a time. It will tend to warp and skew it a little bit. A little bit of a hole there I've got to fill too, but I've got to grind all that back now and make it all look pretty. As you can see, I'm very, very close to being the same level as that flange in there. On the back side, I've got heaps of room, but I'll tidy all that up anyway because it looks like hell. And then we'll flip it over and we'll clearance, but I'm going to let it cool down before I burn myself. And it's 45 degrees in here today. Well, it's an exaggeration. It's actually 42, but, you know, it's hot enough anyway. So get some fresh air, come back. All right, we got those hideous welds tidied up. One thing I've noticed on pretty much all of these that I've done is this little flange down here. You can see he's heat distorted and he's way out of whack now, and it's actually getting into that level. So you've got to give that a bit of a bend down. Otherwise you'll notice it when you go to fit your control arm. So it's pretty simple. Just getting back straight like that. And now obviously I've put all that weld in there where I've already clearanced. So I need to come back through and re-clearance for my washer. So I'll grind all that out of there, and then this will become my stopper on this one, and that will be my stopper on this one. So this is very important to get this exactly right. So you need to hold the bolt nice and square and level all the way to the back, and make sure that you don't take out too much so that this is loose. You want this to be nice and firm in here. And actually I'm sort of curving away a little bit, so I might even put a bit of a weld in here, because you want your stoppers on both sides to be parallel. You'll notice it when we go to put the stoppers on the top. You'll notice what happens if they're not parallel. You get binding and looseness. All right, got those ground out now. So these bolts fit in there perfectly, and they pivot. This one's only going to go one way, obviously, because it hits this. This one here can go either way. It's very tight and grabbing in a few little spots, so I'm just going to give that a bit of more of a tickle. But to sort of better understand what's going to happen, I'll give a bit of a demonstration now. So the bolts drop in like so, and then when you spin them, it indexes on something, and that pushes the actual shank of the bolt over and back in the slot, which moves your control arm in and out, obviously. So you need a stopper so that it doesn't just spin the washer. So put that in there, hard up against the back of it, and then we spin it, and you'll see the actual head of the bolt will move over to the other side, like so. And then we need a stopper on the other side for when we go back the other way, and the bolt sits actually nice and firm in between the two of them. So that sits there like that. And then we go over and back like so. Now, if these aren't square, if you've got them sort of not parallel, you'll find that, see, it binds up this way and then it gets really loose this way, and we can slide them back. We don't want that. So these have to be parallel or very close to it. So hold them on, spin the bolt over and back. Yep, that works great. And we can tack them on. Now, I've included some with the kit. I didn't have any in the prototype. All right, so I've cut up some 10mm strips, or closest facsimile that I could be asked in this ridiculous heat. And now, as I stated, we need to make sure that these are nice and square. So wherever my other bolt's gone to, now is the time to do a quick assembly. Seem to be missing a nut. But anyway, so we'll put a bolt, a washer, a nut together, and we'll spin them around and round and round until we get it in the right spot. And then now you can either fully weld these or just tack weld them on the end. I've just been tack welding them on the end because they're only to hold the washer to stop it from spinning. However, if you want to add a bit more strength, a bit more rigidity, especially on the ends here to stop it from tearing out, you could fully weld them and just add a little bit more beef with that. Again, I've included them with the kit now as opposed to making you cut your own. Okay. You want it to be a little bit loose so that it spins, but not too loose that it can move. Yep. That's perfect. So throw a tack weld on both of them. Still spinning, a little bit firm this way because I've got it out, so I'm gonna have to bump it back that way a little bit. Now this one here, we're gonna have to cut one of these to get it down in there because you've only got very limited space. So, and this one only turns this way, obviously. So, yep. It's a little bit firm, but it'll do. That is tight. So now at this point, if anything's too tight, clearance it. If anything's too loose, add a bit of weld to make sure that they're relatively firm. So this one here, I'm gonna have to probably take a little bit out of the back here. I can feel it hitting there. It doesn't want to turn. This way, we're good. So it just won't go all the way around. So let me get that clearanced on the other side. All right, so unfortunately, my camera overheated in the 42 degrees we had in here yesterday and corrupted the last of my files. So what you see here is what we were aiming for, just putting these stoppers on to make sure that the bolt, you know, drops in. And if you've ever adjusted this style of suspension before, you loosen the nut off and you turn the bolt and you watch the alignment on the, you know, on the laser until you get it to the right thing, and you tighten it down again. So you just want to make sure that with the washer and the bolt both spin freely when they're lightly cracked off and that they bind. That's all there is to it. This flange here, as I said, is very tall and it gets in the way of getting a socket on top of this. So either cut it down or just, I'm going to leave it and just use a spanner on this one as opposed to putting a socket on it. No big deal to me. I do most of my own alignments anyway. So time frame for this, I spent 4 hours on this, including setting up the camera and talking to it. So probably half of that was working. So 2 hours for this side, 4 hours all up. So you could drop your subframe Sunday morning, have it back in the car Sunday afternoon, and confuse the shit out of your wheel alignment guy on Monday morning with whatever this fuckery is. A few disclaimers. I've not tested the long-term durability of this. Obviously, we're moving the suspension pickup points further outboard, which is increasing leverage. We're putting load on places that didn't previously experience load, and we're moving load away from places that were designed to handle load. So do it at your own risk. I have done the mod before, not to this high quality, and it lasted a few races with me at the wheel, and I'm not the smoothest of drivers. So I'm confident enough to do it again, confident enough to market it to you guys. I'm sure you're all responsible car owners. Double check with your rules. If you're racing, moving your suspension pickup points in a lot of race classes is not allowed. It wasn't allowed in my class up until about 2 years ago. Now it is. Similarly, most countries around the world do not allow you to move suspension pickup points for a road going vehicle without it being fully signed off by an engineer. And you probably could get it engineered if you know someone. So double check on your rules before you go ahead. But, you know, again, you're adults and I'm not your dad, so whatever. Bye.